So in this video, we're going to really be talking about displaying and describing data. So this is something that we kind of talked about towards the very beginning. And I want to first note that your x-axis got a little bit funky. So if you'll take a second and just kind of like fix your x-axis on your document, it'll make a whole lot more sense when you're looking at the answer key. So whenever I'm looking at describing distribution, remember we're using CSOCS or CSOCS, and I wrote the acronym out to the side. It would behoove you to get this written down. And remember, I'm always going to kind of get this idea of like, let's draw this distribution, maybe like kind of like highlight that little mountain that those values exist on that histogram underneath. So describe the distribution. Remember, our context is C, that first C. So we're going to say this distribution is talking about age of writers of the beast. Then we're talking about the shape. And the shape, remember we're saying like, okay, we're talking about age of writers on the beast. And the shape, we have this kind of like long tailed to the right, is a right skewed data set. Our outliers are talking about any points that are abnormal. And remember that we can calculate outliers by doing 1.5 times that interquartile range. But we also know that outliers a lot of times persist when there's like kind of these big gaps in data. So we're going to say possible outliers exist from 55 to 60. The center, so we're thinking about where is the center of this data. We know there's five values in this column from 5 to 10. We know there's 25 here. So when we're looking for that center of data, we're going to go ahead and like kind of cross off until we get to that true center. So the 5 cancels with the 5. We have 25 on the left to cancel, so we need to get 25 on the right. So there's 5, 15, 20, 25. Then we need to cancel 35 for this column. So we already have 5, so that's 25. 35, we're going to take 10 away from here and be left with 20. So we know that our center is going to be somewhere between this 20 to 25. So we're going to say the center or median is between 20 to 25 years old. Because our mean is pulled slightly to the right, I'm going to say that the mean is probably going to be a little bit to the right of that. We don't have to worry about that yet. And then you're going to say your spread, the data ranges from 5 to 10 years to 55 to 60 years. So this is kind of how you would go about describing this number 1. And this would kind of be like that FRQ version of this like describe the data distribution. We already talked about all of these values pretty much. The mean is going to be greater than the median because remember like the median is sitting somewhere in the center here. And because it's right skewed, we're saying the mean is being pulled to the right of the median. So that X bar is greater than the median. The range, the median we talked about is going to be somewhere from 20 to 25. The mean, I'm just making an assumption. It's not terribly right skewed. So I would make an assumption that probably the mean would be somewhere between 25 to 30. The two major differences between the mean and the median is that the median is going to give you your middle value, whereas like the mean is a little bit like less resilient to outliers, so it's more impacted. So this 55 to 60 gap right here has way more of an impact on my mean. For this next one, it asks us to organize the data in a stem plot and then also describe the shape. So for this one, I'm actually going to use my calculator. So if I pull this guy up and I go to that stat edit, I would just go ahead, and I already did it, but I'm inputting all those values into that L1. make sure you're pausing the video here if you have not already done so, because like it does behoove you to like do these steps on your own. After you get that done, you're going to click on that second y equals, because that's that little stat plot submenu. And you're going to come down here and like, let's turn one of those plots on. And because we want to make that box and whisker plot or that stem plot, you're going to go over here and make sure you're like clicking on that value that shows that we have outliers included. After you get that, you're going to go to zoom and you're going to come down to number 9, which is zoom stat. And it should take a second. Ooh, we got to make sure that's turned on. There we go. Get that zoom 9, and here we have that plot. So remember, when you're looking at stem plots, it's pretty important to kind of like note some of the key features that are happening here. Let's get a little pic of this going on. So once I look at this stem plot, we're able to get some like really good values from it. So remember, like with a stem plot, I'm going to like annotate this a little bit here. You have your Q1, here's your Q2, Q3, Q4. Remember, this is synonymous with your median. And then this guy right here is going to be your IQR. So these are all kind of like good things to keep in mind. So when I have this stem plot, remember that like when I'm looking at this, it looks like my Q2 or my median, it looks like a pretty like equal number. I'm going to say this is like, the shape of this is going to be like unimodal and like pretty centered. That mean standard deviation and 5-number summary, we can do this a few different ways. So you can just kind of go ahead and like trace on that, and it will tell you if you scroll to like the left and to the right, you can get that 5-number summary. The other thing you can do is you can go over here to like stat calc, and you can do that one variable stats. We have no frequency list, so we leave that blank. And when you press enter, that gives you your mean, which is 39.3. That gives you your standard deviation, which is 23.5. It gives you your Q1, your median, your Q3, your min, and your max. So there's your 5-number summary right there. Your min, your Q1, your Q2, your Q3, and your max. You can also say that, like, what can you say of the shape of the data set? I get a little more clarity here because now I recognize that my mean is actually a little bit greater than my median, right? So that 39.3 versus that 37.5. So because that X bar is greater than the median, we can say that this is going to be slightly right skewed. For that interquartile range, remember you're just subtracting Q1 from Q3, so 55 minus 24. Does the data have any outliers? Remember, when we're doing outliers, we're saying 1.5 times that interquartile range. So we're saying, like, what was that 55 minus that 24? So that IQR was 31. 1.5 times that 31 gives us 46.5. So that median plus or minus 46.5 is going to let us know if there were any outliers. So because that median, let's go back up and check that out. That median was 37.5. And from that value, remember we're saying, like, let's add and subtract that interquartile range. I totally forgot what it was. 46.5. Because we're adding and subtracting, there are no numbers that are going to be lower than or greater than, so we have no outliers. And then here is my box plot right here, and if I were to organize this data into a histogram, we could actually do the same thing on my graph. So you can go to second stat plot. Let's actually turn this into a histogram instead, just to get a great idea. And then let's go to zoom, and we'll go to zoom stat. And then here is that histogram. So you can kind of like see that shape. It has a slight right skew, almost bimodal in a way. but like there's just not enough data on the left side of this gap to call that bimodal. We didn't talk too much about percentile graphs. The idea of a percentile graph is that like the whole thing adds up to be 100. So it's going to look a little bit logarithmic in the fact that like it'll never pass this like idea of 100%. And it's pretty much it's like what you would think it would be, right? So if a 32-year-old rides the Firehawk, we can say like, okay, 32 is about right here. We can take that and pull it up to this graph and say like, oh, that looks to be about the 90th percent. The 40th percentile, we can just go ahead and we're working backwards in the opposite direction. So we're saying from 40 to that line and then we're drawing down. It seems to be about 16, maybe 15. When we're looking at that IQR, remember that's the middle 50%. So that's saying from like the 25th, and let me get like a highlighter here, that IQR is from like the 25th to like the 75th. So if we're asking from the 25th to the 75th, this is essentially like my IQR, my interquartile range. So we're saying like from the 25th to the 75th, that would be that center of that box. So the 25th looks like it's about at like 14 all the way to the 75th percentile, which looks to be about, and I'm just making guesstimations here, right? Like about 21. So it looks to be about like my IQR tends to be about 7. Is 55 considered an outlier? Obviously, if I go over here, if my IQR is 7, 1.5 times 7 is going to be 10.5. So when I look at like 10.5 to my median, remember your median is at 50%. So my median is going to be almost exactly what, like 19? So 19 plus or minus 10.5 gives me like my range for not outliers. So like you would say like, yes, 55 is an outlier because it's outside of that median plus or minus that 1.5 interquartile range. If you were to draw a histogram of this data, would it be symmetrical or skewed? So we can kind of get a really good idea here by looking at like my faux box and whisker plot, right? So here's my median. Here's my like Q1, Q2. It looks like from Q, right, like all the way up to Q1, this is a lot like shorter. So we're putting a lot of data in this small amount where it looks like we have a lot of room here. So if you were to think about that tail, if you were to literally imagine this red line that I just draw and like flip it and like draw it out, whereas this guy right here, right, you like straighten this guy out to be short, it looks like my data is going to be like slightly, or it's going to be skewed to the right because I have some like small outliers, whereas like I have a bulk of that data happening on that bottom end.